Okay, good morning to everyone. In the previous class, we were discussing about some of the favorable conditions for dilutions. Whenever you're diluting, the sewage should be fresh and it should not be converted into a black color. That is what the meaning. Where when it is converting, when the sewage is converting into a black color, it means that DO is completely 0 milligram per liter. In that case, you are not supposed to discharge that wastewater to an river body. Some of the currents, favorable currents, when I am saying the currents, means the mixing should be there in the stream. Means we can say proper turbulence. Proper turbulence should be there um, in the dilution because DO should always increase as it moves from uh, upstreams to downstream. So that's favorable currents. Currents means it is on the flowing um, scenario or the flowing status of the river. Even if um, when the layer by layer, if it is moving, it is a good condition for the discharging the wastewater because layer by layer will come in contact with the surface. Wherever the oxygen that is present in the atmosphere, it is going to dissolve in the water. Automatically, there will be increase in the DO. And the sewage should not be, it should be free from floating and settleable solids. It's very important. Then thorough mixing, that I already said, that is what you can say, it is a turbulence. Always it has to create a turbulence. So, and whatever the diluting water, it should have high dissolved oxygen. For example, the river, if you say, the 8 to 9 milligram per liter permitted. Should not go below 5 also. It is not required. So then, when the city is situated near to the river or the sea, um, of course, in most of the cases, the last sentence, if the city is situated near the river or the sea, it is a good because directly with the gravity, it will reaches to the river. And the treatment is also very easy. Whenever we are designing any this sentence, treatment plants, always it is designed with the gravity flow. Gravity flow. Even after a treatment, even it has to reach with the gravity flow only. So that is why always the rivers, it will be at the downstream, and the cities will be situated at the upstream side. So then we move on to the self-purification of natural systems. This part I already discussed. What is the importance of this self-purification capacity as well as the carrying capacity of any of the rivers. So the automatic purification of natural water is known as self-purification. They have to leave some of the rivers so that um, it will take its own time to uh, reach that status. Then automatically it is going to purify. But you're not supposed to disturb in between the stretches. For example, if you already polluted, assume that this is the stretch. In this stretch, suppose if the flowing in this direction, suppose if this stretch is there, if you are polluting in this stretch, leave this so that it can travel for the longer distance. But you are not supposed to do any activity. You're not supposed to do any activity in this stretch, so that you can leave as it is. As it move towards downstream, assume that there is the upstream and this is the downstream. So you have to leave it as it is, so that the self purification is going to happen as it further travels, but making sure that no further additions or no further pollution should not happen in the downstream stretch. The self-purification of natural water systems is a complex process. It's very complex, as we know that. We'll go ahead how exactly the things are going to happen, because it's a natural process. At every stage we have to determine it, and most of the time, even when you determine it, it may not be correct. So that is why always we have go with some of the 5 to 10% of standard deviation in uh, the measurement of DO or the measurement of pollution at the rivers, because it involves many physical, that is the chemical and biological process working simultaneously. So this is very important. Most of the things, if you are finding the physical activities happening at one stretch, it may not be a problem. Even when the chemical activity is happening at one stretch, it may not be any problem. But if all the things are happening simultaneously, it is very difficult to predict some of the things like what exactly the DO, what exactly the BOD, what will be the velocity, and what are the contaminants which are there at each stretch. It is very difficult, because morning the things will be different, evening the things will be different, afternoon the things will be different. So as the time progresses and during the whole day, or the temperatures go on changing. As the temperatures go on changing, so we have different things which we always have to stress on this, because we have the relations called the DO versus temperature. As the temperatures go on increasing, the DO value will always decrease. So the amount of dissolved oxygen in water is one of the most commonly used indicator for the river health. If sufficient DO is there, then we can say it is healthy conditions. So of course, if you go in detail, many things are there. We'll see in the next further slides how the things will go. So as the DO drops below 4 or 5 milligram per liter, the forms of life that can survive begin to reduce. A minimum of about 2 milligram per liter of dissolved oxygen is required to maintain higher life forms. Even 2 is also not sufficient. Always we have to maintain these standards, 4 to 5 milligram per liter. A number of factors that affect the amount of DO available in the river. So oxygen demand in waste remove DO. Plants add DO during the day, but remove at the night. So respiration of organisms removes the oxygen. So for example, this concept I already discussed. See, as the microbes go on increasing in the river, these microbes will utilize the whatever the oxygen that is present uh, in the river, and the DO go on decreasing. Along with that, the organic matter, whatever it will be there, that is also go on decreasing. So in the summer season, rising of the temperature reduces the solubility of the oxygen. That I already said that the DO versus temperature. As the temperature go on increasing, definitely there will be a reducing the dissolved oxygen. So while lower the flow, this is also very important. Lower the flows reduces the rate at which the oxygen enters to the water from the atmosphere. Even what will happen is, if sufficient flow is there, normally it will come in contact with, as it moves towards the downstream. If sufficient flow is there, layer by layer it will come in contact with the atmosphere. For example, if this is moving, so layer by layer it will move. So this, whatever the layer will be there, it will come in contact with the atmosphere. Then when it comes in contact with the atmosphere, the oxygen that is going to dissolve. But as if the flow is not there, we can say it is a stagnant water. And the stagnant water is that normally we will not prefer even for drinking because sufficient DO will not be there. So then, which are the factors that are affecting for the self purification? So one is that is a dilution. This is very important. This is one impact factor. So when sufficient dilution water is available in the receiving water body, where the wastewater is discharged, the DO level in the receiving stream uh, may not be zero or critical DO due to the availability of sufficient DO in the initial before receiving discharge to the this critical DO I'll explain in the next slide because um, uh, the knowledge of this critical DO is required along with the diagram. So you now the sufficient water should be available. You now the dilution, the sufficient water should be required, and sufficient DO should be required for the dilution water. At that case, you just understand. And the second one, the current. When the strong water current is available, means the flowing what we are turbulence what we are talking about. The discharge water will be thoroughly mixed with stream water, preventing deposition of the solids. This is very important. What is required? When the flowing water will be there, there will be a less deposition of the solids. So in a small current, the solid matter from the wastewater will be disposed at the bed following decomposition and reduction in the DO. So if the solids are not settling, um, means um, it is as it moves, it is not allowing to settle. When it is not allowing to settle, means even the solids will come in contact with the atmosphere. Then automatically there will be a um, if a big solid particles will be there, it will be divided into number of small particles. When small particles will be there, it will be disposed as it move towards the downstream. So temperature, the quantity of DO available in the stream water is more in cold um, than in hot temperature. So that we already seeing. So also the activity of microorganisms is more at higher temperature. Hence, the self purification will take less time at hot summer than the winter. The winter season normally it's a purest form of water we can say. Why? Because the DO versus temperature we already studied, and the saturation temperature at 0 degrees centigrade it will be 14.2 milligram per liter. As the temperatures go on increasing, for example, if you say it is a 30-degree centigrade, somewhere it will be around 9.2 milligram per liter. The third one is sunlight. So algae produces oxygen in the presence of sunlight due to photosynthesis. Therefore, sunlight helps in the purification of streams by adding oxygen through a photosynthesis. This is very important. Whatever the sunlight is there, it is going to help in purification of the streams by adding oxygen through the photosynthesis. Then the rate of oxygen. So sunlight is required. Sufficient sunlight is required, and it should reach to an higher depth. Then one more kind of thing is that fungus. Most of the time, what will happen is that some of the fungi which is there or which is present in the river, that is going to be very dangerous in the stagnant water than flowing water. In the flowing water, the fungus will be very less. But when it is in the stagnant water, if the sunlight, proper sunlight is there, then the fungus is definitely going to rise. Wherever the stagnant water will be there, always we have to target to reduce the light so that it does not penetrate into the lower depths. Then the rate of oxidation. Due to the oxidation of organic matter discharged in a river, DO depletion occurs. It's very important. Due to the oxidation of organic matter discharge, this I already explained how the um, organic matter, organic matter versus um, the microbes versus DO. The organic matter will be there. The microbes will utilize that as a food. Then automatically there will be a decrease in the DO. Then the rate of faster at the higher temperature, low at the lower temperature. Then this rate of oxidation of organic matter depends on the chemical composition of the organic matter also. So this we have to keep it in mind. What exactly the things are, how exactly the chemical composition is going to depends on the um, oxidation of the organic matter. So in this oxygen saccharide, we'll discuss in the next class.